Hello, this is a short video walkthrough of the algorand esp32 solution example. I won't walk through the entire guide online, but I will step through how to build the code, flash the device, and monitor the serial output. As you can see, I've already cloned the repository. I've launched the project in Visual Studio Code, and I have the Platform IO plugin already installed. A quick comment on source. I've tried to keep this simple with all the algorand specific code in the algorand folder. This includes key generation and accessing the PureStake APIs for transaction and account information. Device-specific information for this solution is in the root source directory. I've already updated the constants file with my Wi-Fi SID and password, as well as the PureStake API URLs and API key. At this point, we should be ready to build, flash to the device, and run the program. We start by selecting the Platform IO IDE, which brings up a list of tasks. The first one is build. We select it. It will launch the terminal, and if all goes well, we should see a success at the end. Step 2 is to flash the device and monitor the serial output. To do this, we use the upload and monitor command. But first, we need to make sure our device has power. Plug it into the USB, we see the red light, so our device is on and has power. Select the upload and monitor, again launching the terminal. The first thing that will happen is the IDE will push new firmware to the device. At the end of this process, we'll see a menu from the monitor asking which port we want to use to access our esp32. Here's the menu. We want to select the serial port, which is 5, and we're now monitoring our device for transactions. We check every so many milliseconds, and when the first transaction comes through, we'll see our public address, and we'll see our current balance of algos. Now let's go add money to our device. We'll go over to our MyAlgo wallet and send a transaction. We'll send 2 more algos. We'll copy our public address. Enter our password to confirm. Once the pending transaction is complete, we'll head back to our serial monitor to watch for the output. Note that we're also in the testnet environment. Transaction's complete, and it looks like we've already picked up our additional algos. Now let's test our LED commands. We'll go back to the wallet, and we'll send another transaction. I won't send any algos this time, but I'm going to ask the device to flash its LEDs. You can find the 3 different commands that we've implemented in the guide online. We'll ask it to blink fast. Again, once the transaction is complete, we'll head back over to the serial monitor and watch for it to process. We've received a command to blink fast, and you'll notice in the bottom right, our device is now blinking its blue LED. Because we don't want to let it blink forever, we're going to come back to the wallet, paste our public key, and send it another transaction asking it to stop. Note that we're not using the JSON field here. We had some trouble with the format of the JSON field when we move on to this next step. It was changing the characters of the JSON, but using the text field seems to work fine. You'll notice the JSON field isn't even available at this stage. So we submit our stop request. As soon as the pending transaction is completed, we'll head back over to the monitor and watch for a stop request. And you'll notice our LED has stopped blinking. That's the example. I hope it's been helpful. Thank you.